Alrighty, this is part 1 of our section 11.5, graphing linear functions. This is our slope-intercept form is what we'll be focusing on. Part 2 of this lesson will be about using our graphing calculator, so we'll see both sides of it. And I do just want to make a quick glance at this first example that's listed in the book. We are on page 534, and just briefly talking through example 1. Example 1 brings up discrete and continuous data. And I just want a quick example to help us compare between discrete data versus continuous data. And for this example to compare, I'm just going to think about things we can buy. So an example of discrete data, something that we can buy that would be discrete numbers on a graph. This is a count of items, would be like buying milk. If you go to the store, you can buy a half gallon, 1 gallon, you could buy 2 gallons, but you can't buy 0.67542 gallons. So discrete data means it goes up by some count. Now it might be a fraction or a decimal, but you can't get infinitesimally small amounts of milk. You couldn't ask them for a teaspoon of milk, for instance. Versus continuous data is something that you can get where the numbers between any two data values have meaning, or in other words, you can get any fraction, like buying. So this was like buying milk from the store. This would be like buying gasoline. So let's say you're helping fill up the tank on your car when you stop at the gas station. If you watch, you can buy 0.256 gallons of gasoline. You could buy exactly 1 gallon of gasoline. Maybe that's your goal, is to get to the nearest gallon. But usually it's going to be some decimal amount, and it could be anything between 1, 2, 3 gallons of gas. So discrete would be, I can only get however much milk is in the container. They're certain numbers. Whereas continuous, the numbers in between make sense. Okay, moving ahead to example 2. So now we're on page 535, example 2. And this is going to be focusing on slope-intercept form when we're graphing continuous data. Okay, so specifically continuous, and we're going to use a formula. Slope-intercept form. There are other forms that we can use. We won't talk about those today. Slope-intercept form follows this rule. Y equals mx plus b. Hopefully you notice that m we've seen before to represent something. In fact, we just saw that represents slope. So the slope of my line. And b, maybe you guessed it from the name of this form, is the intercept. But which intercept? B is the y-intercept, or where it crosses the y-axis. Where the line crosses the y-axis. And so, when we see this form, y equals mx plus b, for instance, if I had an example like y equals negative 3/4 x plus 5, then I know the slope of my line is m equals the coefficient on x. M is this number right here, negative 3/4. Remembering what we learned last week, if I was to say, well, what does that negative 3/4 mean? That means from one point to the next, I go down 3 and over 4. And then the y-intercept, b, comes from this number 5. Now I know it's positive 5 because of this plus. If I was to have a subtraction or plus a negative, I I might have something different. B equals 5, but the intercept, a point on the line, wouldn't just be a number. We write this as an ordered pair, where the x value is always 0, and the y value is this y-intercept number. The reason this is always 0 is because it's on the y-axis. And so we would look, and this is example 2 again, or below example 2 in your book, shows the graph of this line. If I saw a line, remember again that when I draw my x and y axis, I put arrows on the end. If I saw this line and wanted to know what is the equation, the y-intercept, where it crosses the y-axis, is at 1, 2, 3, 4, 5. So there is a point at 0, 5. And then the slope is down 3 and over 4. And so if I gave you this line, you might be able to find 1, 2, 3 over 4, the slope and the y-intercept. And in fact, that's going to be our goal today, is to identify the slope and y-intercept, and then to graph some linear functions. Okay, so let's see if we can do that again. Y equals, so this is a new example, and this is actually one of the problems from your homework. Y equals negative 2x plus 5. And I want to know what's the slope and what's the y-intercept so that I can graph them. Well, here again, we have the slope is this number in front of x. And y-intercept, again, in this case, is 5. Or the coordinates 0, 5. It won't always be 5. When I go to graph this, I can use first I graph the y-intercept is 0, 5. Second, I graph another point graph a point using the slope. So the slope tells me the rise over the run to get to another point. But this is not written as a fraction. Remember, just like our quiz, that can be written as a fraction over 1. That was actually the answer from one of our quiz problems. So to get the next point, I would take that rise, negative 2 means down 2, and run means right 1, and I could graph another point. I could do that again, down 2, over 1. And then to finish graphing the line, I need to connect the dots. Much of our homework is going to center around these skills. I do want to show you one more thing, and that will be in our part 2 of this video.